Alright guys, so let's look at what we have here. Today we're talking about linear relationships and proportional relationships. So as you're looking at your graph, you see we have a graph with two different lines on it. We also have two tables here that we're going to be doing some things with. So let's start by reading through our directions. As always, even though this is a recording, when I stop, I need everybody reading the next word. So you've got to be following along with where we're at. Okay? So we're up at the top next to the number 1. Again, when I stop, you're still reading the word that I'm leaving off. Okay, here we go. Nate and Landon are in a 5-minute long hot dog eating. Nate has a special strategy to eat 4 before the competition even begins to stretch out his. The graph below represents what? During the competition. Okay, good job reading, people. So here's what I want to do before we start looking at this graph. We're going to do a little partner talk. Partner ones, I want you to say one thing that you pick out from the information we just read. So it can be really quick. Then partner twos, you're going to say a different important thing that you picked out. So ones are going first. I'm going to give you about 20 seconds here to pick out information. Each of you are sharing one thing that you learned from those 3 sentences. Okay, go. Alright, so we're done with our partnership. I could have your attention back up here on the video. We're going to keep going with what we have. Okay, so let's look. If we look at our graph, we've got a couple things that we want to point out before we get started here. So the first thing we want to look at is that we have our y-axis, okay, and our y-axis is talking about the number of hot dogs. We have our x-axis down here. The x-axis is measuring the time in minutes. So if we look, our hot dogs are going up by 1, so we're just counting by ones. Same thing with our time in minutes, counting by ones. So we'll need that information as we're using our tables here. So let's go down here to our directions for A. So we're right here on A. Okay. Again, when I stop, you guys are reading the next word, so you're following along above the tables. All right, here we go. Complete the tables where T equals in minutes and H equals of total hot dogs consumed. So if we look at our two tables, let's start with the one on the left. Now we're going to work through Landon's table together, but you're going to be doing Nate's table on your own, so you're going to want to pay attention as we go through this. So we have T in our first column. Remember up here they told us T was time. Now if we backtrack even more, we saw that time goes with X. So really T is talking about the X value. So what I want you to start out is we're going to write an X by the T. Okay? The next thing we're going to look at are the H's. So H represented the number of hot dogs. Now we know the number of hot dogs was on our y-axis, so we're going to put a Y where the H is. Now we know from things that we've learned before about slope that slope is y over x. So instead of y over x, they're just using different letters, h over t, but it means the same thing. Okay? So let's start piecing this together a little bit. So the first point that they give us is 0, 0. Now this one's kind of simple because the two numbers are the same, but let's look where they're getting this on the graph. So remember Landon's is this bottom line down here. Okay? So 0, 0 is down here in the corner. All right, everybody, so you're going to help me out. 0, 0 is also called what on the graph? There we go. Good job. So it's the origin. Hopefully you got that. It's the origin. So 0, 0 is the origin. So we're going to fill in what our slope is when we first start at 0, 0. So since it's h over t, we're going to fill this in as 0 over 0. Okay, let's go to our next point. So the next point we come to, we have 1 for t and 2 5/10 for h, so let's fill that in. we're going to have 2 and 5/10 in our numerator and 1 in our denominator. So we'll go ahead and do that. Okay, now let's look real fast at where they're getting this from. So if we look back up here on our graph, remember x is 1, our y or our h here is 2 and 5/10. So what we're saying is if we go over 1 and up 2 and 5/10, we hit this spot. Or if we think of it like slope, rise over run, we're going up 2 and 5/10 and over 1, now we're at our spot here. Okay, so that's where that point's coming from. Now if we look, our t is going 0, 1, blank, 3. So we're missing the 2 value in here. So let's go ahead and put a 2 value in for our t. Okay. Now I'm going to give you a second. Using your graph for Landon, I want you to see if you can figure out what our h will be when t is 2. Okay, or what is our y when our x is 2. So I'll give you a second for that. Alright, so let's look up here. Hopefully you've got it. If we go to t, or excuse me, yeah, t, x is 2, and we go up, our y value, or our h value, is at 5. So we should have had 5 written right there in the h. So let's go ahead and do that. So let's put a 5 here. So that would make our slope, or our h over t, y over x, as 5 over 2. Okay? Let's go down to the next one. So we have 3 and 7 and 5/10. So if we go over 3 on the x, we go up 7 and 5/10. That's the point we're talking about. So let's mark that. Again, we have y in the numerator, 7 and 5/10, over 3 in the denominator. Okay? Now our table is missing our next x value, which is 4, and the one after that, which is 5. So let's fill in our x's here, 4 and 5. Okay? Now I'm going to give you a second. I want you to just finish up Landon's table. So we're going to finish up Landon's table. We'll go 30 seconds. I'm going to set my timer over here. Go ahead and start. Alright, it's been 30 seconds, so let's check how you did. Let's check your work here. So if x is 4, for Landon here, if I can get my arrow to work. There we go. If x is 4, and we go straight up, our y value should be 10. So we should have 10 right here in the h's. So we have 10. Okay? Which makes it 10 over 4 as our slope. And then finally, our last one is already filled in for us. 5 and 12 and 5/10, which gives us 12 and 5/10 over 5. So we have the whole first table for Landon filled in. So I'm going to give you guys some time now to fill in Nate's complete table. Now we're going to check our work together here in a minute. So you're filling in Nate's total table on your own right now. Okay, or you can work with your table partner. Go ahead and start. Alright guys, so take a look up here at Landon and Nate's tables. So hopefully these are our answers we got for Nate's. I wanted you to compare with your table partners as we went, so hopefully working together you guys came up with these answers. So let's look down now that we have our information, and let's see exactly what we're going to be doing with this information. So let's look at B. So we're underneath the table at B. Remember, when I stop, we got to have everyone participating. Alright, here we go. So you're following along. Determine the of change, which is the number of hot dogs per minute for each boy. Now I want you to do something for me. I want you to highlight or underline or circle where it says per minute. Now this word per minute, some of you might already know this, but per minute means 1 minute. Okay, so go ahead and mark that. That's 1 minute. The other thing I want you to think about, I want you to look at, is over here where it says rate of change. Back in our Cornell notes, if you remember, we talked about with constant of proportionality, there's a lot of different names for constant of proportionality. One of them is slope, but another one is rate of change. So when we talk about rate of change, what we're really meaning is they want us to find the slope. So go ahead and put that on there also. So we're looking for the slope per 1 minute for each boy. Okay, so we're going to do Landon's together, and you're going to look at Nate's on your own. So let's look at Landon. So we're looking at Landon's information. Really all we're looking for is when he's at 1 minute. Now if you remember back up here, minutes were our x's, so we're going to our x's down to 1 minute. And after 1 minute, Landon had eaten 2 5/10 hot dogs. So our slope for Landon is going to be 2 5/10 over 1. So down here for our answer, for B, we're going to write his name so we know who we're talking about. So we got Landon, and his slope is going to be equal to 2 5/10 over 1. Okay, I'm going to give you guys about 30 seconds here. Figure out Nate's. So you're going to have an answer for Nate's slope. Go ahead. Okay, a couple things. Remember, slope is always written as a fraction. Now, we're still going to say things out loud even though I'm on a recording. So I need everyone participating, just like when we read. So you're going to all say your answer for Nate's slope. So look down at what you have real fast. Make sure we know this. Remember, when we say decimals, we don't say point. It's something tenths in this case. So it'll be something over something. Remember, with a decimal, we say tenths. So on 3, we're all going to say it. We're all going to fill it in if we don't have it. Ready? On 3. 1, 2, 3. All right, so we should have said 5 5/10 over 1. So we've got their slopes now. So let's look down at C. So for C, what we're doing is we're writing the equation, but here's the weird part. It says we need to represent the number of hot dogs, H, for each boy after T minutes. So let's go ahead and let's mark this for a second. So I want you to underline that H and underline that T, because we're not used to doing that. Usually our equations always start with y equals. So all they're asking us to do is take whatever y is, so we're taking the y out and putting a different letter in its place. So if we remember back up here in our table, okay, back up here in our table we wrote that the H really means the y, and that the T really means the x. So for slope-intercept form, remember our equations always for slope-intercept form look like y equals mx plus b. For this case, though, instead of using y, we're going to use h equals, okay, m, and instead of using x, we're going to have the letter t plus b. So our equation just changes to what's over here to the right in red, okay? Now remember, to find the slope, we would normally use 2 points, but we already have the slope already up above. So we're going to do Landon's together, and again, you're going to do Nate's on your own. So let's look at Landon. So again, it's going to start H equals. Now remember, we already have Landon's slope right up above, 2 5/10 over 1. So we've got H equals 2 5/10 over 1. Now remember, we're not using X, we're using the letter T. Okay, so we're using T. Plus, now we need his y-intercept. Now if you remember, the y-intercept is where the y-axis and our line intersect each other. So back up here, if we look, our line for our y-intercept and our line for the graph hit each other at 0, 0. So our y-intercept would be 0. So it's going to be plus 0. Now we've talked about this before. Sometimes if it says plus 0, you don't have to write it. I wonder if you guys can hear my dog barking right now. But if it says plus 0, you don't have to write it. But I want to get us in the habit of writing that y-intercept, so we're going to keep it. So I'm going to give you a second here. Go ahead and write Nate's equation. Okay, so let's see how we did. Now remember, instead of y equals, we had h equals. Nate's slope was up here, 5 and 5/10 over 1. So we want to keep that, 5 and 5/10 over 1. Instead of x, you had to use the letter t, so t comes next. Plus, now we have to look at Nate because Nate has his just a little bit different. So if we look up at his graph, his line hits the y-axis at a point. His is at where? Yeah, his is at positive 4. So his y-intercept down here isn't going to say plus 0, it's going to say plus 4. Alright, we're almost done with this page here. Let's look at letter D. So it says, for which person, Landon or Nate, is the relationship between time and number of hot dogs eaten proportional? Justify your answer. Now, there's a couple ways that we could go about doing this, but let's just talk about on a graph. So we've maybe I've mentioned this a little bit, but let's talk about it on a graph. Anytime we have a graph, if our graph starts, off at 0, so Landon, see how Landon starts at 0 up here? That means we're proportional. That's one easy way to find it, okay? So Landon would be considered proportional because his graph starts at 0. If we come up here to Nate, Nate's graph starts at 4. Remember his y-intercept was 4, not 0. That tells us that Nate's graph is not proportional, okay? So if we think about this, 0 over 0, remember that was Landon's first point. Nate's first point was 4 over 0. Well, can I do 4 divided by 0? Remember, fractions are just division. We can't do that, so it doesn't really make sense. So that kind of gives it away that Nate's is not going to be proportional because it's not. You can't do 4 over 0. It doesn't work out. Where on Landon's, 0 out of 0 does work out. So as we go down here to write our answer for D, we want to be specific and we want to use complete sentences. So we're going to say the graph for Landon is, and what is it? Is it proportional or not proportional? That's what you got to say. So you should have the graph for Landon is proportional. Okay, because, so we got to have our reason here. Because, and remember, the reason is because his starts off at 0, which is what we want. So Landon's is proportional because his first point is at 0. Okay. Now I'm going to let you write your sentence for Nate. So think about what we talked about with Nate. You're going to tell me if Nate's graph is proportional or not, and then justify your answer for that. I'll give you a second here. Look at question number 2 here. Again, when I stop, you're reading the next word, so everybody following along. Okay, here we go. Again, everybody reading. During her shift at Sweater Barn, Fiona, the same amount of sweaters per 2 hours into her shift, Fiona has sold sweaters. Okay, so let's look at what this is saying. A asks us to find and describe the rate of change, and then B asks us to complete a table. C asks us to make a graph from all this. So let's start back up at the top. The first thing I want you to do is to highlight or circle or underline any numbers that they've given us in question 2. Okay, so if we look at our numbers that we've highlighted, we should have had 2 hours highlighted or marked and 8 sweaters. Now we're going to use that for question A. A says to find and describe the rate of change. Now remember, the rate of change is another way of saying the slope. So go ahead and write that. Rate of change is just another way of saying the slope. Okay? Now as we make our slope, remember slope is y over x. Now I'm going to give you another clue here. Anytime that they give us an amount, that's time. Okay, so if we look at our 2 labels, we have 2 hours and 8 sweaters. So one of those is a time amount. Any time that they give us time, the time is going to go in the denominator. Whatever amount is talking about time, that usually goes in the denominator. Okay? So now, using those two numbers that are up top in our question, I want you to create our slope or our rate of change. I'll give you about 15 seconds here to do that. Go ahead and start. Okay, so I want partner 2 this time. Partner 2, you're going to tell partner 1 what the slope is or what the rate of change that you got. Okay, partner 2's go. Okay, so since partner 2 had to share it at your table, partner 1 is going to say it out loud. So partner 1, remember, it's something over something. And on 3, all the partner 1s are going to say what our slope is. Ready? 1, 2, 3. Very good. So our slope should be 2 over 8. So we have 2, I'm sorry, should be 8 over 2. There we go. So we've got 8 sweaters in 2 hours. All right, so looking down below, B asks us to complete the table where X is the number of hours, which we already knew from our slope, and Y is the total number of sweaters sold. Okay, now I'm going to help you out a little bit and give you some numbers to use just so we're all using the same information here, using the same numbers. So for first of all, we're going to use 1. So our first X is going to be 1. We've already done 2. 2 is up there in our slope, so we're going to keep that. Okay. Then I want you to skip a little bit, and we're going to try number 5. And then after that, we're going to skip again and try number 7. So you need to figure out that if X is 1, or for 1 hour, how many sweaters are made? 2 hours, sweaters, 5 hours, and 7 hours. Okay. Now I'm going to give us a few seconds here, see if we can figure out what B is going to be.